All right, guys, we're looking at 1C here from your Chapter 18 and 19 quiz. Same scenario as A and B. Obviously, countries in Europe report that 46% of the labor force is female. That is a particular p-hat or a particular sample that they took, and they found the proportion was 46%. So that p-hat is 46%. What we actually are looking at in this particular part is they actually select a random sample of 525. And by they, I'm talking about the United States Department of Labor, because they want to create an estimate for the proportion of employees that are female in the U.S. So they go out, take a random sample of 525 employment records and find that 229 are female. They want you to create a 90% confidence interval. So first thing to notice here is, number one, this is a random sample. All right, so if we want to create this confidence interval, we've got to address a couple different things. We know eventually we want to use the normal model to build our sample, but before we can use that normal model, we need to kind of assure ourselves that the normal model is okay to use. So we need to address the conditions here. We address several conditions, and we'll go through that process very quickly. So number one is it random? It is random. It says it's a random sample of 525 employment records. So we make note of that. So that's a check. Number two, we want each particular employment record to be independent of one another. So essentially, one employment record doesn't affect the fact that one employment record shows us that it's a female doesn't affect the probability of the next employment record giving us a female. This one is a little bit murky, not necessarily easily seen. So we'll say not necessarily the case. Proceed with caution for that particular condition. The third condition is going to address that independence issue, and we're going to look for is less than 10% of the population. Used in our sample here. So less than 10% of the population, I'll abbreviate this by just saying less than 10%, and then we make a statement. So in this particular case up here, we've got 525 employment records that we're looking at. So we would say something to the effect of 525 employment records is certainly less than 10% of all U.S. employment records. And then the fourth one here that we want to address is can we expect at least 10 successes and failures in this particular from our particular sample. So what we're looking at is NP, and in this case NP hat. And we would go through and calculate that using our statistics here. So what we've got here is we've got 525 employment records. 229 of those 525 are female. So we've got an N of 525. Our P hat in this particular case is 229 out of that 525. So we can go through and calculate that, plug it into our calculator, and we end up with 0.436 or 0.44. That's our probability that a particular employee is female. for this sample. Again, we're looking to make sure that we have at least 10 expected successes and failures. So in doing so, our sample returned 229 successes, and the complement of that would be the failures. And so we're good on this particular condition. All right, guys, so we went through the process of checking the conditions to make sure that we can use our model here. So we're going to build our confidence interval now. So when we build our confidence interval, we know it's going to be kind of centered around p hat, and we're going to go up a little bit and down a little bit from p hat in order to build our interval. And when I say a little bit, what I'm really specifically referring to is the margin of error. All right, so we calculated our p hat up here as part of our condition, so we know what that is. We'll plug that in later. What we need to do is go ahead and figure out what the actual margin of error is. So how much are we going to go up and down from p hat? So the margin of error is dependent upon us finding a z star or a critical value, and that critical value, we're going to come up here to the confidence interval, and based on that confidence interval, we can calculate that critical value. So we look at a 90% confidence interval. If you don't have this memorized, here's our normal model. If it's a 90% confidence interval, that means 90% is going to be inside here. So what we're left with on the outside when we split it into two tails is 0.05. So if I want to find a critical value, my z star is going to be equal to inverse norm of 0.05. So I plugged that into my calculator, and if you think about what this does, it's going to spit out a z-score for the area to the left, when the area to the left is 0.05. So it's going to spit out a corresponding z-score to that marker on our graph, and that particular z-score happens to be negative 1.96, but we know we can just kind of use the absolute value of that. And I'm thinking back here, I don't think it's negative 1.96. I think in fact it is 1.645. So my critical value will actually be 1.645. And again, you can confirm that with your calculator if you'd like, but that's going to be my critical value for a 90% confidence interval when we split it into the two tails. The second part of this is we need to figure out or incorporate the standard error of the p hats. Now, something should kind of jump out at you there. We're talking about standard error, not standard deviation. Why? The reason is because we're dealing with a sample. We're dealing with a sample proportion, and based on that sample proportion, we will find an estimate for how spread out our distribution is. Well, that's not standard deviation. When we estimate how spread out our distribution is going to be, then we're actually calculating standard error. So standard error is calculated using p hat, or our sample proportion, times q hat. It's actually not much different from what we did before. So it's p hat times q hat over n, and it's the square root of that. Our z star we said is 1.645. So continuing this calculation for our margin of error, we piece it together in this way. All right, so when we plug in our values here, we've got my p hat is 0.44. My q hat is going to be the complement of that, or 0.56, and my particular n is 525 for this here. So I need the square root of that. I'm going to multiply it by 1.645, my critical value. And when I do that, I end up with 1.645 times 0.022. And you can, again, plug that into your calculator and confirm that. That's my margin of error. Simplifying that, I end up with a margin of error equal to 0.0362. So this is the amount I need to go up and down from p hat. So my p hat, again, we're going to go p hat, which is 0.44 in this case. 0.44, we're going to go plus and minus 0.0362, and that's going to give me the interval. When I subtract it, it'll give me the lower end of this interval, which we end up with about 40%, or 0.40. And the upper end of the interval, when we add 0.0362, is going to give me about 47.2%, or 0.472. I rounded a little bit there to make things a little bit simplified. So there's our interval. So the last thing when we calculate an interval, we always make a statement that goes with that interval of what it really means to put it into context. So my statement will look something to the effect of this. We are 90% confident that the true proportion of the labor force, let's say this, of females in the labor force, in the U.S. labor force, is between 40% and 47.2%. All right, so again, just to summarize this, we need to go back and make sure that we state our confidence level and put it into context, and then obviously give the interval in the end.